Hey everyone, welcome to this session on Azure is 100% high available, or is it? My name is Peter de Tender, an Azure technical trainer based out of Belgium, but working for Microsoft for about 2.5 years now. And I would say feel free to reach out when you're watching this live or maybe later on as a recording. The easiest I would say is Twitter. My tweet handle is @PDTIT, or send me an email, petender@microsoft.com. And if you're interested in more technical stuff I'm working on, feel free to have a look at my blog every now and then. It's 007 FFF Learning. Now, before diving into the technical topic of cloud high availability, I need to share one important disclaimer. No cloud is 100% high available. And that's basically it. I would say thank you so much. See you for Festive Tech Calendar 2022. Hope you have some very interesting and nice holidays. See you all next year again. Cool, glad you're still here. Now let's quickly have a look at the topics that I'll cover in this session. Now you know that no cloud offers 100% high availability. It's obviously important to correctly approach reliability and resilience, which I'll talk about first. Next, it shouldn't be a surprise that automation is probably quite important to actually achieving that resiliency and reliability. Now you probably think of DevOps, but no, I'm not going to talk about DevOps in this session, but rather positioning SRE or Site Resiliency Engineering. In the second half of the presentation, I'll walk you through several Azure reference architectures, mainly pointing out where to find them and how they can be useful for you. Closing with a fairly new, as the Grinch would say, an awfully cool service, Azure Chaos Studio, which allows you to run simulated failures to help you troubleshooting before an actual disaster strikes. Looks like in the template we also have a formal About Me slide. Now, I already introduced myself, so what else could be important to mention here? Let's see. I'm an Azure technical trainer at Microsoft, you already know that, and also part of the cloud advocacy team, although it's not part of my official role. I just love talking about DevOps, but again, not in this session. Apart from that, I'm known as pretty passionate about Azure. Been a Microsoft MVP before I joined Microsoft. And in the little bit of free time that I have, I still go back to Azure and writing a couple of technical books. Cool, that's done. So let's jump into the more technical side of things. Now, if a cloud is not 100% high available, the main question is, how available can it be, right? Let's have a look. I'm sure you're all familiar with SLA service level agreements. The cool thing here is that they don't measure reliability. It's actually just a financial compensation metric, when systems are more down than good, to keep customers happy. From a more technical perspective, although not 100% complete because of time constraints in this session, it actually boils down to 8 different terms that are very crucial to know about. SLO, service level objectives. SLI, service level indicators. RTO and RPO, most probably already familiar with. Recovery time objective and recovery point objective. Using SLO first. SLO points at the target reliability for a given workload. Where again, if you think about your own environment, not every single workload needs that full 100% high availability, or maybe as close as 100, right? That's already clear. You might have full production environments where every now and then an outage would actually not really harm the business. Think of like a monthly invoicing report. Is it terrible that it's not running on like the 5th of the month, the 15th of the month? Maybe not. But the crucial time for sending out invoices, which means where you need that invoicing application, is probably at the end of the month. Where on the other side, if you have like an online e-commerce business, most probably you want to have it available as close to 24/7 as possible. And that's what SLO and SLI is going to help you with. And then RPO, RTO again. Recovery time objective is pointing at how long it actually takes before the workload is operational again. And recovery point objective is typically what is the point in time allowing me to actually recover from. and that typically points at potential data loss. Next to that, there are 4 more that I would like to point out here. MTTF, MTBF, MTTR, and MTTA. Cool. MTTF, mean time to failure. It means how long does it take before we have the next outage, or maybe the first outage, right? Mean time between failure is obviously how long does it take before that exact same or a similar outage is occurring again. Mean time to repair or mean time to recovery points at how long it takes before you're actually back in business. And MTTA is mean time to acknowledge. That's typically how long does it take before we actually find out that something is wrong. I would say hopefully your internal IT teams can detect that and you don't have to wait for your customers to actually tell you that the website is down. Good. Now the previous terms and acronyms are measuring the existing uptime of systems, applications and workloads. Great. But besides building and deploying them, a bigger job for most teams is actually keeping these workloads running healthy, which most probably means you're going to rely on some sort of automation, if not for the full 100%, or probably as close as possible. Now, for a lot of organizations, automation in cloud means using DevOps, running CI/CD pipelines. But again, that's not what I'm going to talk about. Partly because I already talked a lot about DevOps in previous sessions. You can find them on YouTube, you can find them all over the place. And by the way, partly because I just want to talk about something else. It's not that DevOps all of a sudden is not important anymore, but in a lot of environments, it's mainly focusing on running some deployments, where I would like to position here what's happening after the deployment. And that's what we call SRE. So in short, what is SRE? SRE stands for Site Reliability Engineering, or sometimes the Site Reliability Engineer as the job role. Originally developed within Google, where the software engineers, together with the technical engineers, sysadmins as we would call them, were actually looking for a more optimized, a better way to handle their system's availability. So what's important here? Reliability, first of all, means guaranteeing that any running application is available. Again, not always the full 100%, but according to business requirements. Some applications need more high availability than others. The engineering part is where you're going to apply the principles of computer science and engineering to build and maintain systems and applications, from the development side all the way to monitoring. Now, overall, as an SRE team, you're going to guarantee workload reliability. That's the one and only purpose of the team. Now, this could range from the design, operating, and technically any process in between to make systems more scalable, more reliable, and efficient. Oh, any idea what the site referred to initially? I can help you a bit. It's pointing at google.com. A nice explanation that I heard from a Google SRE is that their prime job was keeping the website running all the time, because it's probably the first website everyone's connecting to when testing their own internet connection at home, or when you're like traveling and you want to connect from a hotel Wi-Fi, or basically any public Wi-Fi. So if the google.com website was not running, you couldn't really figure out, like, is it related to my infrastructure? Is it related to my connectivity, or is it literally the google.com website being down? Now, in meantime, the site probably could be broadened to overall services, and SREs are typically managing large-scaled data centers on a global scale. Drilling down on the role of SRE would take me probably like 2 days or so. Now, easy said, it can be 3 different core responsibilities. First of all, wearing the developer hat, it's covering writing software for, again, those large-scale workloads. Now, sometimes you're going to take responsibility for the side pieces, like backup, monitoring, load balancing, and the like, being the operations engineer, if you want. And then last, sometimes it's figuring out how to apply existing solutions to new problems. Now, knowing what SRE is working on, how do you divide your time, right? Because you got like 3 prime job responsibilities and you need to figure out like a good balance. based on like what Google initially came up with, but in meantime heavily adopted by other massive cloud environments. Think of like Netflix, Twitter, Facebook, and so many other ones. A good practice from a global SRE perspective is spending about 50% of your time on SRE operations related to guaranteeing uptime and resiliency, where the other 50% is typically going to be used for integrating new features, new capabilities into the application workloads. Now, the key to success is planning, scheduling, as well as having authority, where a lot of team dynamics are defining the success of the balance. Which leads me to the next question. Is SRE like DevOps 2.0, like the new wave of DevOps, right? Now, in short, DevOps is mainly focused on integrating a culture of bringing in developers, operations teams together to collaborate closer with each other and delivering value to the business. Where SRE somehow relies on DevOps practices to optimize reliability. I'll walk you through some demos later on in the session where I'm going to talk about a little bit of SRE in an Azure environment. Now, I always say there wouldn't be SRE without DevOps, but SRE is not replacing DevOps. That's quite important. It's actually augmenting it. So that's basically it on SRE definitions, terminologies. So let's move on and map it with a little bit more on specific Azure topics from here. If you would look down from, let's say, Mars onto an Azure data center, it could simplified look a little bit like this, having 3 core layers. Starting with the Azure Foundation, moving up with Azure Cloud Services, and eventually you're going to run your apps. Azure Foundation is what I like to describe as the fabric, typically the layer that customers cannot really touch, although it gives you some configuration options depending on the service. Azure Cloud Services is where the customer deploys workload infrastructure. This could be IaaS, running virtual machines, virtual network storage, platform as a service, running web apps, containers, functions, and more like that. All the way on top, you have applications. The actual workloads that you are running, you bring them into the cloud. You're going to deploy them, you're going to manage them by using your IT teams, developers, DevOps teams, or why not SRE teams if you already have them. Important to emphasize here is that using Azure is shared responsibility. Out of Microsoft, we need to provide a reliable Azure foundation. Think of the physical data center, connectivity, allowing customers to build their level of reliability and resiliency on top by implementing the cloud services layer, where you might think of availability sets, availability zones for virtual machines, integrating global load balancers to redirect traffic across different Azure regions, or maybe deploying multi-region storage replication, database replication. All that will result in reliable application runtime. Now, how do you get a view on Azure Foundation reliability? Easy said, we do have a service for that. Checking Azure Service Health. Azure Service Health is actually a combination of 3 different tools. There's Azure Status. That's going to provide you the overall Azure Status Health. And I'll show you in a demo in a minute what it looks like. From there, you're going to drill down on Service Health, allowing you to provide a personalized view of your running Azure services and the specific regions that you are using. From there, you're going to drill down on Resource Health, sharing a status of your individual cloud resources, like web apps, virtual machines, and whatnot. Now let me show you in a quick demo what this service is all about. Cool. So from here, you go to the website status.azure.com, where it's going to pick up your regional language. And from here, you can validate what is the current real-time, refreshing every 2 minutes, availability of almost any Azure service across the different Azure regions. So in my case, based out of Belgium, I'm probably most interested in the European environment, but obviously it all depends on the use case, where for each and every Azure region, and you already should know that they're growing every couple of months. So even Europe used to be West and North Europe, but it's heavily expanding. where you're going to find out what's the availability of each and every service. Every now and then when I'm demoing this, it's like, yeah, but this is nothing really dynamic where I can tell you that luckily for now, everything is green. That's the fun part in talking about this service or this dashboard. And honestly, it's not always all green. So obviously, based on the criticality that you can find up here, it's going to show you how it's running. All green means everything's up and running, but sometimes there's a warning. And worst case, like what's happening right now with AWS in East US, where the full region is unavailable, we're going to flag it as a warning and every now and then shifting to critical. So that's mainly what this is about. From here, this is again high level, just from that Azure Foundation I talked about, where it's also allowing you to drill down on your specific services. So you can move over to this Azure Service Health, and that's going to bring you to a more specific, more detailed level of information and mapping with sources that might actually have an impact on your environment. Again, some part of this demo cannot really be prepared for because it's pretty dynamic and I have no idea what's happening real life in an Azure environment, but it's going to show you the service issues, information about planned maintenance. Every now and then, we also have planned maintenance in our Azure data centers. And whenever something is not running as it should be, we're going to make you aware about it. So for example, here, like a couple of days back, so from here, it's going to show you more detailed information. In this case, Microsoft Graph. And that's mainly what Service Health is about. Cool. Now from here, let's move up in the stack and covering Azure Cloud Services reliability. The best thing to start from here, although again, remember, it's nothing super technical, but in the end, it's all boiling down to SLAs. The Azure SLA portal, it's more like a landing page where you can find a lot of details about each and every Azure service and the corresponding SLAs, together with the architecture that might influence your SLA. For example, if you look at virtual machines, and again, I'll show you in a minute what it looks like. It's slightly different depending on the virtual machine topology architecture you're going to deploy. For a single virtual machine, the SLA will be lower than if you deploy availability sets or if you deploy availability zones. So as a solution architect, a cloud architect, maybe an SRE architect, I would say one of the next steps in the stack is looking at your SLAs that your cloud vendor, in this case, Azure, is providing, and from there mapping it with your business requirements. If your business requirement is looking for a higher SLA than what the service can offer, it means you need to adapt your architecture by maybe expanding to multiple regions, maybe looking at other hybrid or multi-cloud scenarios. That's mainly what it means. And from here, quick demo, no rocket science, I would say, but nevertheless quite important to get an idea what Azure SLAs are all about. Cool. So in this next one, a little bit about our service level agreements SLA dashboard. So you go to the dashboard page, and from there you can start searching or selecting any of the product services. So for example, go to compute, virtual machines, and for each and every virtual machine architecture, it's going to provide you some insights. For example, here, for all virtual machines, 2 or more instances getting deployed across 2 or more availability zones, the SLA will be the full 99.99 or the 4 nines as we typically describe it in the industry. You could deploy an availability set, again 2 instances or more, and that's going to provide you a 99.95 SLA, so a little bit lower than availability zones. If you deploy a single instance virtual machine, you're going to see that again, the SLA is dropping a little bit, but there's also some interaction with the underlying storage integration. So if you want a 99.9 SLA, you need to configure your VM using premium SSD or ultra disks. And if you're going all the way back to probably the lowest SLA we offer virtual machine using the standard hard drive, the SLA is dropping to 95%. And that's basically the same for all other services, all other resources. So why is this important? Because again, it's a big part of your high availability, reliability architecture. Let's do the same for containers. Azure Kubernetes Service, where it's going to tell you roughly about the same, because Kubernetes, although it's a little bit invisible for you, but it's still based on a virtual machine underlying architecture. So you deploy AKS guaranteeing 99.95 for the Kubernetes API server, like the brain as I call it, and the cluster nodes, deploying within an Azure availability zone, giving you 99.9 for the cluster itself if they're not using Azure availability zones. So that's how the two scenarios are nicely coming together. Obviously for Kubernetes specifically, this is only touching on the underlying Azure service layer. You can interact with your Kubernetes to obviously make your pods, your containers, more high available within the cluster itself. Two examples on IaaS, but you have the same for web apps, where you could look into app services. Another easy example, where app services is somehow, I would say, a little bit easier to talk about, because all Azure app services are coming with the same SLA, 99.95. The exception here is that there is no SLA for the free or the shared tier. So main message, all SLAs for all Azure available services are available here. Quite important, before actually deploying anything, make sure that you are familiar with your SLA statements. Awesome. So now we have our foundation. We talked about SLAs. So from here, it's, I would say, more responsibility from your end, where you're gonna figure out what would be the recommended reference architecture for this kind of workload. Now you don't have to reinvent the wheel. Why? Because we offer you out of Microsoft a full Azure reference architecture in a couple of different modalities. The first one I'll talk about for a second is Azure the Well-Architected Framework, or WAF. Well-Architected Framework zooms in on 5 different technical domains: cost aspects, performance, security, operations, and reliability. Now, I would personally recommend becoming super familiar with this framework. Whenever you're talking to a customer, an internal department, or if you're working for a partner and literally talking to end customers, make sure you become super familiar with the WAF, Well-Architected Framework. Why? Because it helps you achieving ultimate reliability together with all the other building blocks. For existing customers, you could also look into the Cloud Adoption Framework, but that's more about like how do I onboard to Azure, where the well-architected one is typically, I would say, referring, although it's not exclusive, but it's assuming that you already have some architecture building blocks up and running, and from there you're gonna optimize them. And again, in any of those 5 pillars, that would be the main scenario. Now, based on that, architectural building blocks coming out of the well-architected framework could be summarized in, for example, using zone-aware services where available for virtual machines and, for example, Azure web apps. Use global load balancers to redirect traffic to failover regions. Load balancing, high availability, active, passive, across different regions, and on top you need a global load balancing service. Think of Azure Traffic Manager, think of Azure Front Door, just 2 examples. For virtual machine workloads, deploy them high available, obviously first of all in a single region, and from there, why not looking into disaster recovery using Azure Site Recovery or Azure Backup scenarios. For database services, again, deploy them redundant within the same region and preferably across multiple regions, where Azure gives you a lot of different database scenarios, starting from relational, SQL, MySQL, Postgres, or the more non-relational databases, where Cosmos DB could be a good example because it's super performant and super reliable. And then again, for those platform services outside of virtual machines, again, look into backup configuration options, for web apps, SQL, Cosmos, and some of the other services I already mentioned. A few more: integrating governance RBAC policies, which typically means make sure that your admins, your DevOps teams, your SRE teams can only touch what they are allowed to touch. Integrating Azure policies to lock down specific deployments. You can deploy a specific set of virtual machines. You can only deploy a specific virtual machine type or a web app service or anything else in a dev and test subscription, but not in a production subscription. So basically all around governance. Make sure that you can deploy across different environments. Dev and test, Q&A, production, obviously, but maybe also look into canary deployments, early adopter, blue-green, if you're familiar with those. Automating as much as possible. Using DevOps practices, DevOps tools. Could be Azure DevOps, could be GitHub, GitHub Actions, or why not any other third-party DevOps pipeline scenario. And last, more towards observability, integrating end-to-end monitoring of your workloads. That's like a well-architected framework in a nutshell, where from here, I'm switching to another demo, quickly showing you where to find information, although I presented the links like 2 slides back, and quickly walking you through some of the core WAF capabilities. Cool, so from this Azure well-architected framework I talked about, this is what the landing page looks like, and it starts with the different pillars. So for each and every of the pillars I mentioned, reliability, security, cost, and operational excellence and performance, you're going to find the exact same overview down here. And from each and every of them, it's allowing you to drill down. Since I'm mainly focusing on high availability, reliability, let's zoom in on that one for now. Starting with an overview, like what is the reliability pillar about? You can read the doc, you can watch this video as well, providing you some nice integration from David and some of his colleagues. Like what does it mean to build an Azure reliable workload? From there, it's having pointers to different building blocks, talking about regions, availability zones. If you have no real idea what it's all about, you can click through from there, actually going back to the official Microsoft docs that we have on the Azure landing page. A lot more details on definitions, acronyms, synonyms, anything that you're looking for that might be important, helping you in getting a better view on what it's all about when discussing reliability, can be found here. I'm not going to bore you with clicking around and showing you more stuff, but one of the other interesting scenarios here is running an assessment. Again, remember in my presentation a few minutes ago, I mentioned that we have the Cloud Adoption Framework, or CAF, as we typically describe it, and that's mainly for organizations that are not really using cloud yet, where the well-architected framework is somehow, and again, it's not only targeted to those ones, but it's super useful if you are already running cloud workloads in Azure and you just want to find out what is my current high availability, reliability, security, cost, optimization perspective, and literally going through an assessment. So the first step is obviously enabling the assessment. From there, you're going to select your specific workload type, where I want to find out the information about my well-architected review. Clicking next, allowing you to select any of the 5 pillars, where again I'm mainly zooming in on reliability. And what it's going to do here is presenting you a list of assessment questions. Up here on the first level, it's only showing like maybe 10 or so, but in total it's probably around 30, maybe even more than 30 questions. So let's quickly click through, and for each and every high level, it's going to allow you to filter more details. So up here, what reliability target metrics do I already define for my application? Where I got my composite SLA already in place. We talked about MTTR, MTBF, and let's move over to the next question. How have you ensured that your application architecture is resilient? Nothing. And obviously going through all the other questions, so speeding it up a little bit. So all the way at the end of the assessment, answering the last question here, it's gonna provide a nice overview summary. It's gonna provide a status, and it looks like there's quite some effort still to be done to make sure that my environment is running healthy, running full reliable as it should be. And again, for each and every of the core building blocks out of the well-architected framework, it's going to provide you some details. Where again, for now, just a quick demo. I'm only zooming in on reliability, but you could do the exact same for all other workloads and workload pillars, security, cost, and there's also the same for specific Azure machine learning and data management. Awesome, we're slightly moving on. Now, I briefly touched on some of the core characteristics of what it takes to actually build more reliable, secure, optimized Azure-based workloads. But where do you find all that information, right? The good news is we have it all documented. Already touched on the well-architected framework, but that's not the only source. The next one is Azure Reference Architectures. Azure Reference Architecture is a subset of the massive Microsoft Docs website, specifically providing, reference architectures. It's really that easy. Besides being just another description of what it's already available in the docs, it's actually way better than that. Managed by a specific team that's part of the broader Azure engineering product groups, the team is combining the best of the product group information together with experience from the field on how Azure services have been and are getting deployed at larger customers across the globe. For now, there's a little bit more than 500 different validated architectures to choose from, available for specific Azure services and also for specific industries. Think of e-commerce architecture, think of a finance organization, think of healthcare, who might have some specific requirements that might be specific for that vertical industry. Or you could also start from an Azure service, like starting from how to architect your Azure DevOps environment, how to integrate serverless, microservices, Kubernetes, how to build high available cross-region networking, and so many others. Now, from a content perspective, it's what I describe as the blueprint for any cloud solution architect. It always comes with a Visio diagram, providing the solution architecture, references to the core building blocks in the Microsoft Docs pages. Often it's going to help you providing ARM templates, CLI deployment templates, allowing you to literally deploy it in a quick and easy way. And if there's some additional source code available, or sometimes sample apps to validate the architecture, there's also a pointer to GitHub repos. That's it in a nutshell. So you could already figure out, I got another quick demo on that. Nice. So with that, one of my last demos, I would say, for today, showing a little bit what the Azure Architect Center or Reference Architect Center is about. So as you should already know by now, by following the presentation, it's all about providing you like blueprints, giving you literally that architectural overview for a lot of different services. So you can filter based on technology. So there's AKS popular article, how to design a web API architecture, how to integrate natural language processing in like the AI space, how to organize or choose a data store, how to integrate DevOps, and so on and so on. Or from here, let's say I'm interested in figuring out what hub and spoke network topology is about. And as mentioned, it's providing you a lot of details, starting from a reference architecture diagram. So up here, it's going to highlight, this is what the virtual hub and spoke network is about. You have your on-prem network up here. You want to interact with Azure, probably using ExpressRoute or site-to-site VPN. You need to deploy Azure Bastion as some kind of jump server hosting security environment for your virtual machine workloads running Windows or Linux. Integrating Azure Firewall for the purpose of any firewall. If you're not using ExpressRoute, there's a fallback scenario using VPN Gateway. Integrating Azure Monitor And what should be interesting from here is that although we're talking about hub and spoke networking, that it's not just touching on the VNets, the subnets, but also touching on a lot of other site services where, again, the reference architecture comes in, telling you that it's not just about deploying the network resource, but also integrating the security, integrating optimization, integrating monitoring, for example, and that's why it's all part of that reference architecture. From there, if you have no idea how to deploy it, there's a couple of Azure CLI examples in this case. If you don't like CLI, but you do have a background in PowerShell, you can do the exact same from here. If you're looking into automating deployments using Azure Resource Manager, you could also look into the newer way of deploying ARM templates, and that's what we call Bicep. And if you don't like the templates in a command line scenario, you could also immediately go over, clicking that deploy button, and it's literally providing you that hub and spoke ARM or Bicep template, allowing you to literally deploy what we showed in the diagram. The explanation, like the use case, why this reference architecture could be useful for your organization, and from there drilling down on each and every architectural building block, and that's again pointing to different parts in the platform. Just one easy example. Let me take one step back and also showing you that, for example, again, just a couple of links here on the screen. If you want to integrate microservices, Kubernetes alike, Azure Functions alike, if you want to find out how should I deploy my pipelines, what would be my pipeline scenario, let's pick one of the more complex ones, building out a CI/CD pipeline for microservices on Kubernetes. Again, providing you all the details where you need to have source control Git-based, allowing you to interact with feature branches, committing the changes, building a YAML-based pipeline, integrating with pull requests, building out the full CI/CD build, running different environments, isolating environments for security, typically security purposes, creating your Docker file with some sample applications you can use, running a test, and eventually integrating with, for example, Helm charts, and all the way down automating end-to-end using Azure DevOps pipelines with everything that comes with Azure DevOps pipelines, using YAML syntax, moving to different stages, different environments. That's what it's all about. And from here, as you can see, there's a lot of details for almost all 200 plus Azure services we have. But on top of that, we also provide you that vertical industry overview. So if you're active in something that I'm actually really missing after 2 years in this pandemic is travel and hospitality. So imagine your customer or your organization is active in travel and hospitality industry, and you want to build a bot integration on your public website, interacting with potential customers, teasing them to actually go out and visit your hotel, maybe automating or helping them automating the process in making a hotel reservation. What you need is a chatbot relying on Azure Cognitive Service. Starting again with a high-level architectural overview, what are the building blocks? You're gonna need Azure Bot Service. You're gonna need the language understanding LOIS, and you need the speech services. Those are like the core building blocks. Next to that, you have some mobile app front end. You might have a web integration. You need identity coming from Azure AD B2C, for example. A web app that's presenting the bot engine, that's presenting maybe, why not, your web application itself, and storing some information in some sort of database engine. From there, the different scenario steps, step 1, 2, 3, 4, 5, 6, and so on. And again, pointers to the different components, covering high availability, scalability, security, and again, just a click of a button to actually deploy this sample reference architecture. And why not, all the way down, also talking a little bit about potential pricing impact when you deploy this kind of reference architecture. And that's mainly it. I could talk about the other 500 something Azure reference architectures we have here, but most important, drilling down based on the service scenario, or why not starting from some reference architectures based on the industry vertical your solution is mapping in. That's mainly it. Whoa, quite impressive, no? Now, with everything I discussed up till now, you should be fairly comfortable in having an Azure-based workload up and running, which integrates reliability, security, cost efficiency, and overall optimization. But we all know that systems are dynamically changing, which means the longer they're running, you probably need to touch them. You need to change them, you need to keep them up and running. There's new application versions, new container versions getting published, which might impact the reliability. So your work as a cloud admin is not quite done yet. And you should also be looking at unplanned outages and trying to mitigate them where possible, obviously before they occur. Now, one really cool and new service available in preview to help you with that is Azure Chaos Studio. So let's have a look what it's all about. Well, if you're wondering what Azure Chaos Studio is about, it's, let's say, whether you're developing a new application that will be hosted on Azure, you're migrating an existing application to Azure, or operating an application that already runs on Azure, it is important to validate and improve your application resilience. That's mainly the message from my session. Resilience is the capability of a system to handle and recover from interruptions, disruptions, right? Disruptions in an application availability can result in errors, failures for the end users, which in turn can have negative consequences on your business or your business mission. When running an application in the cloud, avoiding negative consequences requires you to validate that your application responds effectively to those disruptions. Disruptions caused by the failure in the service, or maybe even disruptions to incident response tooling and processes. Now, chaos experimentation enables you to test that your cloud-hosted applications are resilient in Azure. Think of some scenarios. Now, honestly, there's a huge amount of examples, a lot of reasons why you should look into this. And remember, for now, it's only preview, so a lot could still change, and typically in a positive way, right? For example, it allows you to reproduce an incident that impacted your application to get a better understanding of the failure node, or ensuring that post-incident repair items will prevent the incident from recurring. Or maybe you want to perform some application performance benchmark testing, or overall running stress tests, running load tests, and figuring out how your application architecture is reacting on that. It also allows you to obviously get a lot more confidence in the services that you build using the cloud native architectures that might not always be that familiar with. It also allows you to perform business continuity disaster recovery drills to ensure that your application, whenever gets impacted, can be easily recovered, and literally going through that drilling exercise. Now, within Azure Chaos Studio, from a technical perspective, it's using what we call chaos experiments. An experiment is just like any other Azure resource, holding the failures to go through. That's what you can see here in the diagram as the blue section, and which resources to target, which would be the green section. Overall, there are two different approaches to failure testing: service direct and agent based. Service direct allows you to directly target any Azure service and running some availability testing. For example, targeting an Azure web app, a function, or a storage account. You could also go for agent-based, allowing you to run failure testing against an IaaS-based scenario like virtual machines, but why not also the underlying Kubernetes infrastructure, for example. A chaos experiment is based on a three-layered approach. You start with defining a step. Within a step, you're going to define a collection of branches. And within each branch, you're going to specify the actual actions or tasks to fulfill. And that would be your failure actions. For example, here in step 1 in branch 1, I'm going to target a system and simulate a high CPU load pressure, generating CPU spiking to 99% load during the next 10 minutes. The target, which is defined in the selectors all the way down at the bottom, can be different for similar branches. In this example here, it's targeting a group of virtual machines, but we could also reuse the same CPU load testing against, for example, a cluster of Kubernetes nodes, or why not targeting an Azure web app. And that's mainly what Azure Chaos Studio is about. So from here, I'm going to switch to my last demo, quickly showing you how to target, for example, a Linux virtual machine and simulating that CPU pressure example that I talked about. So you open up Chaos Studio, and within you're going to find targets and experiments. So a target is the Azure resource that you want to use to test your fault injection against, and the experiments would be the actual testing plan. So when moving to targets, it's going to allow you to select all the specific Azure resources that you have in your subscription. You could filter on resource groups, searching for example here, an Ubuntu virtual machine that I'm running in a specific Azure region. Now, as you can see from here, it's already enabled because I prepped the demo already a little bit just to speed it up. But what you can do is flagging your resource, and from there enabling target, where a target can be that service direct target for basically anything that's not a virtual machine, or a virtual machine scale set, and obviously the other scenario, like in this case for my Ubuntu VM, would be an agent-based. There's a couple of configuration steps required in order to make it ready for agent-based target, where probably one of the first things is creating a managed identity for your Chaos Studio experiments, and next to that, you also need to enable the managed identity to that Ubuntu VM. So let me quickly switch to the details of my Ubuntu VM, where within you're going to dive into the identity settings, and from there you go to user assigned, and as you can see, I have a specific user assigned managed identity that I created for my Chaos Studio object, and I'm going to link it to my target resource. Once we have that in place, it's going to deploy that agent, and everything is somehow magically starting to run. Now, the next step is allocating specific actions. So for the agent-based, you can click on Managed Actions, and from there it's going to provide you a specific list of fault injection actions that you can go for. Now, for now, I'm going to make it a little bit easy, straightforward example using CPU pressure that I'll talk about in a minute. But just to give you some idea about potential validations you can run, there's a CPU pressure, obviously. You can run a memory pressure, virtual memory pressure on Linux, disk I/O load on Windows and Linux, stopping services, shutting down VMs, and basically anything that allows you to literally validate if my virtual machine or the workload that's running is not functioning anymore as it should be because of high CPU load, because of high memory load, and that's literally what you're going to simulate. Second step here is creating an experiment, where again that experiment is that step-by-step instructions definition that allows you to link specific actions to a specific target. Now for this one I already created one, but I can dive into the actual settings. So what you're going to do is defining the step, the branch, and an action plan, right? So the step and the branch is basically allocating some descriptive name, allowing you to know what you're actually going to test, but technically could be about anything. And probably most important is allocating a fault action. For now, and again, it's preview, there's a couple of interesting scenarios already available, like shutting down virtual machines, interacting with Cosmos DB, a couple of different steps based on the Chaos mesh, allowing you to target AKS Kubernetes environments,
And from there, the ones that I already talked about, specifically related to virtual machines. So for now, let's go for CPU pressure. We're going to run this load for X amount of time. The default would be 10 minutes. And let's simulate a full 99%. For next, you're going to target your Azure resource, in this case, the Ubuntu VM that I already selected, and confirming the steps. Now, I'm not going to save it because I already created this one, but interesting here is that you could also define a delay, which means that you could create a sequence of faults, and in between you could define some delays, like I want to run this fault simulation like every 20 minutes, every 30 minutes. I want to simulate something and moving it into a pausing state for X amount of time. That would be the main purpose of the add delay option. Once you have all this in place, we're almost there. So one step back, and one last thing we need to do is defining that this new chaos experiment, which by itself is a standalone Azure resource, we need to provide it role-based access permissions to read the target resource. Now, in the scenario I explicitly defined it on the virtual machine level. So I can go into my Ubuntu VM once more, and within access control IAM, you can specify the reader permission for that chaos experiment. In a larger environment, I can imagine that you might link this to a specific resource group, maybe linking it to a resource group level or a full subscription, or selecting it, allocating it, and that's basically what I already did. And from there, it means we can finally run that chaos task. So one step back into our Chaos Studio. Where you're going to select your experiment and basically running it. That's like the only thing left to do. So you click that start button, it's going to start the fault injection, runs for about 10 minutes, and in between it allows you to follow some process or the progress, like how it's running, if it's running, and eventually, like you can see here, a demo I built like a couple of hours back, providing you the details. And if all goes fine, I can go back to my virtual machine and actually show you what the CPU monitoring looked like at least a couple of hours ago. So there was a little spike from a couple of hours back, and as you can see here, it was running, my virtual machine was live. That's where the fault injection CPU load kicked off. And interesting enough, here I have no idea if it's like some bug in the settings or maybe a bug in the reporting. But although you define 99% CPU load, it's actually never going above 85. So wouldn't worry too much about it. I mean, in the end, I'm pretty sure if your machine is under heavy load, it's not really going to make a huge difference if it's 85 or if it's like 99. But that might be something from the preview, but something I'll probably check with the product team. But that's basically it. Again, so in short, you create your fault detection, fault simulation based on agent or direct service scenario, allocating it to target, running the experiment, and basically validating what's happening. So that's in short what Chaos Studio Preview is all about.
Cool. Obviously, I hoped you made it all the way through to the end and you also enjoyed watching the session. By now, you should also learn more about Azure High Availability and how to optimize resiliency, reliability for your cloud running workloads. I discussed briefly at least the concepts of SRE site resiliency engineering, touching on the Azure well-architected framework as a guideline on how to properly build your Azure environment using security, performance, cost, and obviously reliability. I closed with a quick intro on Azure Chaos Studio. Again, definitely a service to watch out for. Currently in public preview, allowing you to simulate failures and mitigate them before they happen. That was almost it, but one last important message here. This year, the Festive Tech Calendar team are raising money for the charity Girls Who Code. Now, we believe that it is important to support good causes who work to improve equality, diversity in the tech industry. So if you would like to donate, please go to this link and throw in some money. It doesn't need to be a lot, but it's always nice to stimulate and support the community as well from that perspective. And that's, I would say, my closing message in my session. Thank you for watching. Thank you for listening. I hope you learned from it. Hope you enjoyed a couple of demos that I did. And from here, I would say already happy holidays and hope to see you again for the next edition that's coming up next year. Enjoy your holidays and stay safe and healthy.